The microelectronics are the brains of these systems, right? That enables our warfighters to see and do the world around them with more than just what they can see with their eyes. The packaging is really how we bring everything together. When you fabricate a chip at a foundry, those chips have to be able to connect to the outside world. We're putting chips together on top of each other, next to each other. We're linking them together with different components, put them into something that brings them all together and adds performance. Instead of just being the sum of the parts. The commercial world may be focused on certain things that defense isn't, but we can learn from each other. We can leverage, we can tweak, we can augment, we can add to in the defense space to get the extra performance, the extra reliability, the extra things that we need. There's a huge gap in the onshore industry to be able to support this technology here in the United States. And we've invested heavily in our own capabilities to be able to meet the needs of our own programs. 2 years ago, our company formed what we call the Northrop Grumman Microelectronics Center. We looked and said, there is no one facility that can encompass all of these needs, that the ability to, second point, is scale into a production volume.
Hey, Dave, thanks so much for joining us here on Micro Journeys. It's a pleasure to have you on the podcast. And you've been extremely busy with all of these, major announcements with Northrop Grumman and the such. And I'm thankful that you've been able to, take the time out of your schedule to sit down and chat a little bit about microelectronics and your journey here.
Yeah, thanks, Dan. I appreciate you having me here.
So, let's kick it off with, how did you get the passion for microelectronics? A lot of people come from a variety of different angles, everything from, having a professor or early on. What was your journey and how did that start?
Yeah, so I'll proudly put on my nerd badge here and take you along what's been a long journey that's led me to this point here. So, full disclosure, dream job was and still is, I would have loved to have been a Blue Angels pilot. Coolest thing ever. So, I'm still a huge Blue Angels fan. And, there's times where I'm like, oh man, I wish I was doing this for my day job. But as far as how I got to the microelectronics side of things, I always had an aptitude for building things, for working with my hands, for just figuring out how to make things, right? And so as I went along through, grade school and into high school, right, I was one of those weirdos who, basically arrived, around the, college selection time frame, and I was like, all right, how many degrees can I get? Because I didn't know if I wanted to be an aerospace engineer or mechanical engineer or an electrical engineer. Everything was cool, and it changed based on, any given moment and what specific thing I was learning or tinkering with, right? So, one of the things though that happened along the way was that in my later years of high school, I went to an ASM materials summer camp where I ended up going for my undergrad at Missouri University of Science and Technology. And that was where I sort of realized that I was finding a home in that from a college discipline perspective, because rather than having to pick, a specific field, right, as far as, one of the main engineering disciplines and, choosing if I was going to make airplanes or cars or something else like that, right? The material side opened me up to the fact that, hey, all this stuff is made out of something, and somebody needs to engineer those materials and work those structure property relationships and figure out everything so that way the other engineers can actually build the things that we see flying in space or driving around on the ground, or, functioning as our microcircuitry that powers all of our, daily lives from an electronics perspective. And that really spoke to me because it combined all the disciplines, and I sort of looked at it from the standpoint of I can go work in any one of these fields because they all need to make their stuff out of something. So that's where I ended up going. So I did my undergrad studies in ceramic engineering first at Missouri S&T, and that was a really cool experience because I got to, go into a lot of different areas and find out what I liked. So I was doing ultra high temperature materials research at a point. So, we were learning how to process materials for, rockets and, airplanes and things like that are, unmeltable materials sort of things. So did that for a little bit. Also did some work in glass science, and actually in glass art too. So I got to see the connections between things like properties of materials and how you make them, and then also how you can make art of them out of them. So S&T was pretty cool in that right at the time where I was there for my undergraduate, the ceramic engineering program was actually standing up a glass blowing shop. So I was one of the first students that got to do that, and at an amateur level, but like I made some pretty cool big things, but not a Dale Chihuly or anybody professional like that. But it was cool because you got to see outside of the lab and the hard textbook studies that there's more applications applications to these engineering fields than you may even realize. And then that ended up leading to, all right, I wanted to go into electronics, and so I was doing electronic ceramics, which took me a couple different places across the country for some internships at places like Sandia National Labs, and good experiences there. But at one point, I sort of realized as I was working on my master's thesis that I'm basically like, all right, I'm doing some really cool things with cool applications, but I'm basically sitting here grinding powders like a chef all day. And I said, I want to play with really big, expensive pieces of equipment doing very sophisticated things. And so one of my mentors, basically said, all right, well, if you want to do that and stay in the materials world, you should look at going into semiconductors. And that's what led me out to the East Coast to do wide bandgap semiconductor research at the University of Maryland as part of the materials science and engineering program there. And that's where I got my PhD from. So that was a cool journey for me because I went from doing probably the one of the dirtiest engineering disciplines to one of the cleanest now, because I'm spending all my days in the bunny suit and operating equipment and doing all the button pushing and things that was super super exciting to me.
Well, it's
That
and it's covers so much overlap in
mhm.
semiconductors, right? I mean, just from the example you used with the glass blowing, right? Looking at phase change diagrams
Yep.
and things of that nature, and seeing the material properties that are very different from one material to the next. Glass being one of the
Mhm.
substrates that is heavily utilized in a
Exactly.
lot of semiconductor applications. To some of the stuff you're talking about with ceramics. I mean, the whole Department of War is surrounded around how materials can enhance all different types of
Yep.
applications. I mean, it's one of the quintessential pieces for things like hypersonics, right? So
Yep.
it's rooted deeply in a lot of the advancements for high technical capabilities in material science, material engineering. All of those pieces are usually looked over. People focus on, electrical engineering or civil engineering or mechanical engineering as being the top tier way
Yep.
of helping to enhance the Department of War. But material science is what I believe, the foundational piece
Exactly.
for many of these new enhancements that we see in all of these different types of
Yeah.
applications.
And I have to remind my, friends and colleagues, especially the electrical engineers somewhat, but the chemies especially, I have to remind them that, all right, look, there's materials combines all that stuff. So don't get too high and mighty on me there as far as who's the best engineering discipline.
Oh yeah, I'm leaning in your favor a little bit here.
I can tell, and I'm glad to hear it.
Yeah. While you were starting out at Northrop Grumman, what did you
Mhm.
start doing while you were there? I mean, since Northrop Grumman has such a wide swath of different applications, was it right away in the lab? Were you doing more of a design piece? What was your, entry into Northrop Grumman?
Yeah, so another interesting set of the journey, that happened after I joined Northrop Grumman. So, to your point, Northrop Grumman is a huge, defense contractor, and we've been doing microelectronics for 70 years at this point, right? So, we have a deep heritage in those kinds of technologies, but that's actually not exactly where I was going to start. Sort of, but I came in through a program that we have called the Future Technical Leaders Program, and it's for master's and PhD grads new to the company. And basically, it puts you in three 1 year rotations all across the country, right? So pretty much, if you can find the opportunity, or if the program can find it for you, you get placed in a very high impact technical leadership role. In any part of the company, really. So you could be working on the aerospace side, you could be working in the microelectronics side, and when I came in, right there, the company's trying to figure out, okay, well, where do we place you, right? And they can't tell you everything that you can do yet. You're not, officially vested in the company yet, so there's some vagueness around, okay, what rotation do you pick and where do you move to? And so, I was working with my mentor in the program at the time to figure out, okay, well, do I want to go do something completely different, like systems engineering, on an actual platform program? Do I want to go do fundamental research, sorts of things, right? Where do I want to land? One day he calls me up though as we're trying to finalize the selection. He goes, I got the perfect job. You're gonna get a call from these two people, Helen and Pete, and I promise you this is the one you want to take. I'm like, okay. So they call me up, and this is where the packaging journey for me really started. So they were looking for somebody who had experience in either advanced packaging or in semiconductors that you could parlay into advanced packaging to more or less define the manufacturing organization's road forward to implement these technologies. We knew they were coming. They were in the Pathfinder systems and the DARPA programs and things like that. And they said, we need a technical expert who can go and learn everything that there is to know about this and chart our path forward. So I said, great, sign me up. That sounds like fun. There were a few terms in there that they used that I hadn't heard publicly at the time that I thought were something different, like digital fabric did not actually mean wearable electronics. It meant factory connectivity and cool stuff. But there were a few times where the person who called me, who would become my boss for the next 6 years or so, we had some back and forth gotchas over some of the buzzwords that Northrop used that tricked me into thinking it was something else. So but that's really where it started. And then from there, I got into more roles and responsibilities with sort of being the packaging SME and technical leader. I ended up actually breaking all the rules of that rotation program. So I stayed with that organization, with that boss for actually all three rotations and the final placement opportunities, because I went from sort of managing, being a subject matter expert and managing some research and development type efforts, to then actually managing the full stand up of some very significant capital investments that we made in Baltimore and in Florida to build out more advanced packaging capability at the company, which is now the basis of our packaging open access offerings.
So before we get into
Yeah.
all of that detail, some
Sure.
of the listeners, they're coming in a variety of different
Yeah.
levels of understanding. With the Northrop Grumman and microelectronics, right?
Yeah.
What do you mean by they're involved in
Hmm.
microelectronics? Because I mean, aren't all the primes involved in this? What sets Northrop Grumman aside or is different
Yeah.
in the application of what they're doing with with microelectronics?
Yeah. So the first thing I'd say there that's important really is that the microelectronics are the brains of these systems, right? They're how they sense the world around them. They're how they react to it. They process. They that enables our warfighters to see and do, right, the world around them with more than just what they can see with their eyes, right? So this is really what underpins everything we do. It doesn't really matter what the platform is. There's microelectronics somewhere inside of it. And there's a lot of overlap too with non-defense type applications in commercial communications, commercial computing, et cetera, that also are things that we parlay into the defense sector and for commercial users too. So the microelectronics piece of this is very important, and where Northrop Grumman's gone as a company, and what's led to our microelectronics center organization and the open access offerings, is that for decades we've invested in the capability to do our own microelectronics and packaging manufacturing operations. So,
So what do you mean by packaging?
mhm,
Because maybe to the layman, they're thinking packaging like you would get from Amazon or UPS and the such. What is packaging, and how does that, integrate into the entire overall supply chain of microelectronics, right? Because there's
yep,
different segments associated with it.
exactly.
Where does packaging fall into this? And really, why do people care?
So that may have been one of the gotchas I was telling you about that I joked with my boss about. And just for reference, I think there actually is I think it's somewhere in, I want to say it's in the Air Force. There is a center for packaging life cycle excellence or something that actually does the shipping boxes and things like that. So that was another gotcha when I'm like, ooh, we should talk to these guys. And then I realize it's not microelectronics at all. The packaging is really how we bring everything together. It's the connections, right? When you fabricate a chip at a foundry, those chips have to be able to connect to the outside world. And packaging is how we do that, right? We're putting chips together on top of each other, next to each other. We're linking them together with different components. And ultimately you build from, this custom designed chip that does whatever function it needs to in the system. And then you're putting it all together so that way it can reach out and interface with the whole airplane or the whole whatever the platform is. The basis of that, after the chips come out of the foundry, all the processing steps that happen, all of the things that, join the chips together, is really what advanced packaging is all about. And we're really focused, and the industry, I think, is really focused on figuring out how to take more chips, more functionality, and putting them together into smaller and smaller packages, so that way you can do something like take the big sensor on the top of the E2 and convert that into a package that's the size of your hand, of your thumb.
So the way I understood what you just said there is that you have these, designs, whatever it may be, and then they get manufactured
Hmm.
at a fabrication facility. And Northrop Grumman has these kinds of
Yep.
capabilities, right? And from there, when they're done, these devices need to find a home or find a way to talk to the rest of the electronics.
Exactly.
And this is where the packaging piece comes
Yep.
in, correct?
Yep.
Now, what's the difference between, normal packaging and you reference advanced packaging?
Mhm.
What's so advanced about it? Or what's different than just your normal package?
Yeah. So when we talk about advanced packaging at Northrop Grumman, it's really about how do we bring all of that functionality into the smallest space possible. And oh, by the way, how do we not only make it, how do we test it, how do we cool it, how do we do all the other things that we need to understand fully about it to put that part, that assembly, into a functional system. So what is sort of the legacy technology, right, is where you have a chip and you're actually like bonding wires onto it from the sides, right? That's a technology that's never going to go away. It's very low cost. It's very mature. Like those things don't fail, and we still build a lot of parts that way through ourselves and through external sources. But when we talk about advanced packaging, it's collapsing all of that into a much smaller footprint. It's adding more chips together that are not produced in the same materials from the same fabrication sources, and putting all those things together into this ultra compact package that then operates and does something more special than the components that were in it just individually.
Oh, so the way that you just described that, it sounds like real estate matters in electronics. So the size, the
Mhm.
weight, the power associated with this.
Exactly.
If we can compress all of that into these advanced packages, it just benefits the overall system, its functionality, its utility.
Mhm.
Am I tracking this correct?
Exactly.
Okay.
And this is the same sort of journey that I'd say that the commercial world is on, right? How do you make a cell phone smaller? How do you make it have a longer battery life, right? We may use the term, swap C, size, weight, power, cost, all of that stuff, right? Commercial industry may say PPA, power, performance, and area, right? Those they may mean different things or have different levels of complexity depending on the application, but it's all focused on basically how do you miniaturize what were separate, discrete, large components and put them into something that brings them all together and adds performance. Instead of just being the sum of the parts, it's actually more than the parts that are all put together. So it's kind of one of those weird 1 + 1 = 3 kind of situations
Yeah,
that
but
we're
then
trying to
add the
achieve.
additional variable. I mean, a router just sits in someone's, cabinet or closet and, it just operates as is. Where in the world that you live in, I mean, you have your traditional use, but your irregular use as
Mhm.
well. So there's got to be ruggedized pieces associated with this. There's got to be high reliability associated with this, radiation effects. So now you have all of these compounding variables that are going into something that the commercial world really doesn't have to think about, right?
Yeah, that's true. There's I mean, you mentioned a lot of the big ones, right? So we do care about how these devices and how the packages perform, and that necessitates sometimes different technologies than what's in the high volume commercial wheelhouse, in order to be able to support and maintain. And those are things that our warfighters depend on for decades long time spans that we have to make sure that we can address.
And you guys are able to leverage the lessons learned from the commercial space, right? And then put, let's call it your secret sauce
Mhm.
for defense applications, correct?
Yeah, I think there's a lot of complementarity, right? The commercial world has been paving this road for a long time, right? I would say that the complexities can be in different ways, right? So the commercial world may be focused on certain things that defense isn't, but we can learn from each other, right? So I think that's an important part of the journey from a system and from a microelectronics perspective. That the huge body of work that's been done in the commercial space we can leverage, we can tweak, we can augment, we can add to in the defense space to get the extra performance, the extra reliability, the extra things that we need that you don't have a reason to have in your cell phone, but that we do have a reason for in the defense space.
So we were going down a path when you were saying, yeah, this is what led me to advanced
Hmm.
packaging over in Florida, and I kind of brought us back a little
Yeah.
bit to talk about kind of setting a foundation of what advanced packaging was and the such. But you were describing your journey back over to Florida and how
Hmm.
your integration there was starting out. So why don't you continue down that?
Yeah, so that was the second part of the journey at Northrop Grumman, was ultimately building out capability to do the things that we couldn't get from other onshore sources, right? So obviously, being in the defense space, we and most of our customers are prioritizing getting their parts from trusted sources, right? Places where you know that your part, your IP, the system performance, et cetera, is all protected, so that way it can't be used, against the company, or it can't be used against the customer, and it can't be used against the country, right? So we looked at the landscape of advanced packaging, particularly towards the defense applications and these things that are still very necessary to, I'd say, fairly high volumes, but not like commercial cell phone type of volumes necessarily. We looked at those and said there's a huge gap in the onshore industry to be able to support this technology here in the United States. And we've invested heavily in our own capabilities to be able to meet the needs of our own programs as well as outside customers. That's the defense industry, the other primes and lower tier defense contractors. We work with a number of them. They are coming to us, and we're collaborating on these packaging technologies and how we meet their needs. And that even goes into the commercial space too. So, we have a long history of particularly operating in commercial spaces, things like the satellite communications market. So, if you've flown on a commercial airliner and used the Wi-Fi, somewhere in that comms chain from you to the rest of the internet is actually probably a Northrop Grumman chip in there. So, we've got a lot of experience in those areas where actually the defense expertise helps meet the commercial users' missions as well.
Interesting. Huh. So there's a bleed over here
Yep.
that Northrop Grumman has been able to
Hmm.
to find. It's not just supporting the Department of War; it is expanding into commercial, and I have to assume even into some of the civil applications that are
Hmm.
out there as well. Correct?
Yeah, and I think, as the geopolitical landscape has shifted, right? There's a lot of focus on onshoring of technologies, and our facilities are here, right? We built them up here. We're not bringing things back from from foreign countries. Our facilities are here in the U.S., across the country, and they're ready to go, basically, to help meet these needs that our customers are bringing to us, both defense and commercial.
Well, this is a great topic to hit on. How is Northrop Grumman addressing this? I mean, it's something that there is now kind of a arm's length that the United States is putting towards, some of the overseas manufacturing of items. With the focus that you're describing here in Florida, has there been an ecosystem that has been built out by Northrop Grumman to help support not only demand but the onshoring manufacturing capability?
Yeah, so we work within the ecosystem in the United States. We're an active partner in there. I would say that we go as far as, when we're treating defense system needs, right, and we see gaps in the ecosystem. We'll take an honest look at, is this something that we need to do ourselves for particular reasons, or is this something we need to find a partner to do? We do both of those models, and so we have some very successful collaborations in the industry where, we've actually transitioned a technology out for a part of that packaging ecosystem. We've transitioned it to domestic suppliers who are going to scale it. In other cases, we've invested ourselves, particularly in things like wafer bumping and package integration, where we're actually doing the assembly of these chips together, and the test. As we're integrating more of these components together, those are things where we've invested ourselves, in order to meet the needs of the customer base. So, we're an active player in that whole ecosystem, and ultimately, I think our goal is to bring together, a partner base that can work together to meet the needs of the U.S. industry that requires their parts to be fabricated in either secure or onshore facilities.
Well, it does take a village in order to meet all the microelectronics requirements. We've talked a little bit about this capability over in
Hmm.
Florida, and one that you're really leading the charge on.
Yeah.
What is the capability that is there, and
Mhm.
and and how is that such a beneficial piece not only to the nation but to Northrop Grumman?
Yeah, so our focus in Florida it has been around the post-processing steps, where you take a wafer out of a foundry and you need to put whatever interconnects on it to put it into that package that we were talking about before. That there's many different kinds of interconnects that we use on these systems, on these chips, to meet those reliability requirements and cost targets and environmental regulations and things like that, depending on whether we're talking about the defense or the commercial space. And there's different wafer sizes too. So our two foundries in Maryland and in California, right, they produce at a particular wafer size for the devices that they fabricate. We also use a lot of wafers from the foundries that are onshore, and those can be at the larger wafer sizes, like 8 and 12-inch wafers. And
So
so,
you can take wafers from a commercial facility, let's say Skywater, Tower, Global Foundries, one of those
mhm.
pure play facilities, and package it over in Florida
We do that
along with you do that
we do that
already.
we do that every day.
Interesting.
Yep.
And also your own supply. So
Yes.
in Lithicum and in California, you're able to do that and create this, I guess, packaging capability that is a high mix of technologies all across the United States,
Mhm.
at which you were saying at relatively low volumes for these, ruggedized or, military types of applications, correct?
Yeah, that's been our goal, right? Is to be able to take essentially a wafer out of any foundry, put the interconnect that the customer requires onto it, and assemble it into that package and test it. So those capabilities are in Florida. There's other parts of that process that happen at our other facilities in the country, but they're all trusted, DoD accredited and secure facilities, so we can meet those needs. And I'd say from a volume perspective, right? We really target the sort of market space where we need to be able to scale from everything from a one-off, DARPA level prototype, all the way up to millions of units a year sort of things, right? So not necessarily high volume commercial type of markets, but definitely a lot more scalable and higher volumes than you'd see out of maybe other facilities in the country. It's not just development; it's definitely full production too.
Well, this is a monumental shift. I mean, from a prime contractor,
Hmm.
Northrop Grumman, typically these kinds of relationships are very siloed. I mean,
Hmm.
from my experience, I've seen other primes, and I won't go through all the details of which ones they are, but they usually don't work well with others. I mean, they usually kind of keep their own, systems aligned with their own, requirements and their own basically self-serving kind of needs. You're saying that Northrop Grumman has done this paradigm shift now where you're saying, look, we have so many microelectronics requirements as a nation, as a Department of War. We need to now work with this village, create a pure play offering that allows all people that are working towards the same goal, which is national security, to leverage our facility. Do I have that right?
That's exactly right. So 2 years ago, our company formed what we call the Northrop Grumman Microelectronics Center, and that's the organization that I currently support as the head of advanced packaging for the Microelectronics Center. And we took a look at our capabilities, our facilities, and the national need, right? And I'm going to go beyond just national security and say that's users who need a secure access to facilities across the United States.
So, Department of Energy, Department of
Yep.
Commerce, I mean, anyone that has a need from a national perspective,
Yep.
you guys take it on.
That's correct.
Wow.
So that we basically took our foundries and our packaging capabilities and put them under the Microelectronics Center as a business unit that can meet these needs. We have the ability to work with the other primes. We have the ability to work with the government. We have the ability to work with commercial users too. So, this is the first time I think in Northrop Grumman's history where we've had all of our microelectronics reporting to the same business leadership, so that we can offer what our customers are asking for to give them a holistic solution. And if it's not something that we offer, we probably know who does, and we'll bring them into the mix so we can address the customer's needs.
Yeah, that's a pretty big shift from a leadership perspective to identify this as being, not only a core capability that you guys have, but a corporate driven direction that we're going to make sure that there's this ecosystem that is aligned, that is all functioning in tandem, so that way we can take on not only our requirements, other prime requirements, nth tier suppliers, commercial applications,
Yep.
and be able to service them here domestically. That's and in a secure fashion, right? So that is pretty interesting. So with regards to the advanced packaging
Hmm.
piece, what are the current capabilities that are there in Florida? Why would someone entertain leveraging Northrop Grumman versus XYZ company somewhere else across the nation? What sets you guys apart, and what is the kind of the core capability there?
So I think there's three key points to this. One, I'm going to go with flexibility. So we were talking about different interconnects to meet the needs of the customer mission and the customer application, right? There's different wafer sizes coming out of different foundries. Some of them need lead solder balls that are humongous, components. Other ones need these little tiny copper or gold, metal bumps on them. And, that all depends on what the mission architecture is and what the customer ultimately requires at their package level. But we looked and said there is no one facility that can encompass all of these needs at the ability to, second point is scale into a production volume. So tens of thousands of wafers a year sort of thing with all these different interconnect types. Generally, you'll either see, in the commercial space, there's one interconnect type, maybe two. right? That a facility can do. They can only do it on 1 or 2 wafer sizes, not all of them from 4 inches to 12 inches, and not with the variety of materials that we can put on there. So some of our applications require ultra high reliability, and they're still, in what the commercial world would say is the dinosaur ages and using lead solders. We have the ability to do that. We can do lead free to meet commercial applications that have to comply with, some of the international environmental regulations. We can process the wafers that are coming out of our foundries. We can process them at the 12-inch wafer size. That ability to both encompass that level of flexibility, but do it at a scalable volume up to meet our customers' needs is something that's very unique about us. I think the other thing is, with Northrop Grumman's, sort of at the top level of Northrop Grumman, right? We understand systems. We understand how these things work, how they're built. We have the ways to protect our customers' IP within our company and from the outside world. So we can work with them, but we can bring that domain expertise, here in these all these different kinds of systems, and basically help them meet them at their mission need, right? So that way we're not just a pure play facility that, give us a design, we'll build it to print. We can actually help them solve their problems by understanding what is it that they're really trying to do in a secure and IP protected fashion.
And you guys have gotten quite a bit of press with this kind of shift as it relates to, having this open access piece, being able to integrate in, like you said, some of the legacy capabilities from a packaging perspective to, state of the practice to
Mhm.
now state of the art, taking on these large wafers. I mean, there was a great segment that was, I believe you were interviewed on with Fox Business. So that was pretty exciting. And I think it's now becoming a nationally recognized capability where others, sometimes those that have been long-standing customers of Northrop Grumman, but also some of your competitors have said, look, in order for us to be successful, we have to be able to integrate in with, this vision that Northrop Grumman and yourself over in Florida have had, right?
Yep. And I mean, that is core to our mission, right? We are open access. We are servicing the national need, right? We looked at all these great capabilities and said, this is not something that we should keep to ourselves. And the country needs it. So that's where we've gone. The Fox News or Fox Business piece was entertaining, if for nothing else than, my family photoshopped a bunch of backgrounds behind me when they saw me on that. So that was an entertaining thing. But I think, the core of that was really getting the word out that we do this. So, a lot of people don't realize, first off, that Northrop Grumman actually does microelectronics. They know us for the big platforms. Things are flying in the air or in space, or, ship undersea. Like, we do all of those systems as a parent company, as Northrop Grumman, from undersea to outer space. They don't realize that the microelectronics heritage is what makes all those things work, right?
Well, it's a foundational technology,
Exactly.
right? So I believe all the success that Northrop Grumman has, understanding that that is a foundational piece, right? Worth
Exactly.
investing in.
Exactly. And the open access side of things, we've actually done that for 30 years, right? Our West Coast foundry in Redondo Beach has sold, externally to the commercial world for 30 years. So, bringing these things under the common business leadership was a priority for us, but we're actually taking what we already have done and already know how to do, and we're expanding that to cover all of our microelectronics and packaging capabilities to meet that national need.
Well, and the national lead to compound what you guys are solving as far as a problem. I mean, it's referenced quite a bit with the impact that COVID had, right,
Mhm.
and all of the different nations finding a way to prioritize microelectronics with investments and
Mhm.
a lack of supply chain capabilities and the such. And instead of sitting there playing your little violin, you guys decided, hey, no, we can actually solve a big portion of this
Yeah.
problem, right? And it's interesting to see how you guys have taken that on. Now, with the all of these different surrounding capabilities that you have, where do you see the future of the not only the let's start with the Florida facility. How do you see, the next set of steps growing there and meeting the demand
Mhm.
of, the Department of War, Northrop Grumman, and I guess the commercial applications as well?
Advanced packaging is a very rapidly evolving technical field, right? I mean, there's been many conferences around that technology. We're seeing a lot of, adoption and new technology implementation coming from both the commercial world and the defense, right? So that's getting recognized a lot over the last, 7 years or so since I started this, right? It was kind of a niche thing maybe before that, but now it's really a mainstream push. But advanced packaging encompasses so many different technologies. It can be, how do you have to make the interconnects on the wafer. You have to assemble that onto something else, right? How are you doing all of that? There's different technology needs, different platforms, different like technology platforms, different processes that are developed to do, the missions from, let's say, fundamental RF stuff all the way out to, digital and AI processing and things like that, right? So it's an evolving space, and we're really working to understand, what do our customers need in order to be able to meet their mission needs. How do we reduce that swap for them? How do we reduce the cost for them? How do we improve their performance, right? And what are the technologies that we need to be working on to go beyond what we have today in order to meet the needs of tomorrow? So I think that's really our future. As far as where we're going, we've identified some key technologies that we're rapidly prototyping with, that augment onto the capabilities that we have, that'll ideally turn into some external offerings that we can bring to bear. But that sort of stuff is still being worked on.
Interesting. So if I'm a commercial entity and I'm saying, hey, you know what, I need to go and leverage Northrop Grumman for packaging or fabrication stuff. I mean, do I just go on the Northrop Grumman website and just click on, hey, services provided, or how does one interface with
Mhm.
with Northrop Grumman?
Yeah, so we have a website. I think it's www.ngc.com/micro, and that takes you to sort of our corporate homepage for microelectronics. It gives an idea of our offerings, right? And we have a lot of different flexibility options between our foundries and our packaging capabilities, right? Everything from buying a sort of a turnkey product, like there's a chip that's already designed, we already, you just sort of buy that as a standard part, all the way up to a full custom, like come to us with your idea on a napkin or a PowerPoint slide, and let's figure it out together. So that web page is the start. It's got the key connections at Northrop Grumman that you would interface with to address those things, along with data sheets and sort of the standard things you want to look at for the standard product offerings. But going back to your point about advanced packaging and where does this go forward, right? We're seeing these technologies hybridize together, quite literally, to make the next generation of systems. So that leads to a space that really, the best place to start is, go to the website, find one of us at the Microelectronics Center organization, and just start the conversation with us, because the plans from there, once we understand what our customers are looking for, across, again, primes, ourselves, commercial users, right, we can really help architect a solution around what they need in order to meet their needs.
So just so I'm thinking about this correctly, this is operating as a pure play capability.
Yeah,
Anyone can utilize this. This is not operating as a Northrop Grumman cherry picking who to work with and the such, correct?
that's correct. It's fully open access.
Interesting. So, and that's going to help drive a number of different initiatives. The White House is pushing out things like Golden Dome, for example. NC3 is being another one. F-47. There's a lot of these different systems that are out there that are, very high on the list at the White House, in ensuring very rapid timelines and deployment to secure our nation. So with your guys' capability, even if Northrop Grumman bids on some of these items and others are bidding on these items, they can still utilize the pure play capability, correct?
Exactly. And that's one of our foundational principles with the Microelectronics Center. We can protect that information, just like, I mean, we're protecting classified information and other things every day, right? So protecting and securing that IP for our customers, we know, is a foundational element of the open access, and we take that very seriously. And basically, we're here to serve, again, that national interest, regardless of whether it's a Northrop Grumman customer, or it's another defense prime, or it's a commercial world. Our job is to be there to meet those customer needs.
So Northrop Grumman as a whole, we talked about the Florida piece here, taking it now to the Microelectronics Center
Hmm.
piece. What is the vision there, and how do you guys, or how do you see the growth to continue happening to
Hmm.
meet the demand of microelectronics? I mean, it's such an evolving space, right? Every single day, there's a new announcement of something that is redefining state of the practice or next generation state of the art. I mean, the internet is saturated with updates. How is Northrop Grumman's and your perspective the vision to meet those kinds of demands?
Well, for one, it's a really exciting time to be in the packaging space. I didn't realize that when I got into this space 7 years ago, right? I mean, if you'd asked me if I was here, if I was going to be here, at that time, I would have told you were crazy, right? Um, and I think the vision is really to become a critical infrastructure part of the microelectronics ecosystem for the country. We have been for 70 years, but that's been primarily captive to our internal programs. Right now, the vision is to make sure that we are foundational to the entire industry. And look, we don't do everything, right? And that's where we partner, but we have a lot of capability, especially to meet these, more customized needs that our customers are coming to us for. And we're now in a mode where, like, there's certain technologies that we see are going to be foundational to all of this, and we're looking at what comes next, and we're listening to our customer base to say, what are your challenges, right? Do you need a specific technology that you've identified that you need deployed and scaled from a demo to a full production environment? Do you need something that nobody's actually come up with yet, right? Do we have to go invent the future together? Those are all conversations that are part of our vision to be that critical microelectronics provider in the ecosystem.
So it's partly, following the trends of what industry is doing, but also getting feedback from those that are working with you to help kind of drive this roadmap for microelectronics that Northrop Grumman is following. Do I have that right?
Yeah, that's part of it. I mean, if you look at our microelectronics heritage, right, the DoD, Department of War, and that the entire defense industry, right, we're leaders, have been leaders in microelectronics, especially in certain areas, right, and we expect to continue that leadership overall, right? So there, like I said, there are things that we are looking at that leverage commercial technologies, and it may just be, all right, we need the ability to do this in a particular environment, right? Then there's the, how do we augment that to go beyond what the commercial world, the commercial applications demand in order to achieve something new. And then there's the, nobody's figured out how to do this yet, and we need to go invent a fundamentally new type of technology. That's that, and scaling those approaches into, like I said, that medium volume production is the sort of thing that we do every day, and makes it an exciting place to work.
So I kind of jumped ahead and said, "What's the big vision here?"
Yeah.
But let me pull it back with something a little near term. What's the, I guess, next big thing for Northrop Grumman, the microelectronics capability, the Florida facility?
Hmm.
Is there anything that the listeners should be tracking as far as kind of a major highlight that's about to come out?
Yeah, so we're about to wrap up a pretty major expansion geared towards 300 millimeter automated wafer post processing there. So again, flexible interconnect types, and gets us that scalability into tens of thousands of wafers a year in terms of capacity at those larger wafer sizes. That's something that we've been working on for the last probably 2 years or so to grow to that next step. That's going to be wrapping up here towards the end of this year, and we're actively working with our customer base to understand their needs, their volumes, and get that planned in so that we can address what they're looking for.
Well, it's interesting, going back to the beginning of the conversation. Your dream job, right?
Yeah.
It was to be a Blue Angel pilot, and in a roundabout way, you're helping to influence all the pilots within, the Department of War, not only the Blue Angels, but the Air Force and the Marines and anyone that flies anything based on the work that you're doing in microelectronics, which I think is, something that doesn't get the same amount of publicity that the Blue Angels do, but like we said, it's foundational to many of the different applications that are there. So, Dave, it was a pleasure having you here on the Micro Journeys podcast, and looking forward to seeing not only the major successes that you continue to roll out over in Apopka, microelectronics in general, but just continuing to remain friends and seeing your journey as things go on. So, thanks
Absolutely.
again.
It's been a pleasure. Thanks, Dan.